Hello. Uh, I'm glad to see so many people here actually, because I thought the last session would actually only have like 5 people maybe at most. Well, we have. It's pleasant. I hope you will not be disappointed. So I'm going to talk about visualizing code bases. First of all, let me talk about the background which I have. So yeah, I'm a developer. By the way, how many of you guys have been in my session? And not many of you. So I'm primarily a developer, but I do a lot of automation and I do a lot of code analysis as well to identify the direction, identify the architecture and stuff like that. And yeah, let's go into the topic. So I often find new clients because I'm a consultant, I'm a freelancer, and also doing some projects with them sometimes with many people. And it always a project that I'm coming into, it's like it already exists for a while. So it's not a new greenfield project. It's something that already was developing for some time. So, and usually the code bases are relatively huge. And I need to have quick analysis and basically also provide quick results to my clients to show that I'm actually useful. So I have developed some kind of simple techniques that I usually use to understand what kind of code base it is, what kind of hotspots are in that code base, and where to start digging further. Because yeah, code bases can be quite huge, and you don't have time to read that all. Just to compare what kind of code bases I usually face, so Google code base, the whole Google code base, all the products, is about 2 billion lines of code. Facebook is about 61 million lines of code. And the code bases that I usually face is like from small ones, from 20K to 2 million lines of code.
Sorry to ask, how did you get the number?
You mean the
Google and Facebook?
It was published somewhere.
Okay.
Actually, I can show you later on. I have a nice infographic comparing different code bases from different big companies like Linux kernel, Microsoft Word, all that stuff, and it's very nice. I can show you later on. But just to give an understanding of kind of things I usually face and what I have to analyze. And the big code bases, the 2 million line code bases, usually it's like big projects, and roughly, usually it's like 50% of that code is useless. But anyway, this is the size. And obviously, when I face a 2 million lines code base, I don't want to read it. I hate reading it because it's just I have no chance to understand everything and have no time to read everything. So yeah, I love this infographic, or it's a comic basically. So when I go into someone's code base and then trying to understand what is going on, I kind of see these reactions from time to time. So it's not that pleasant to read, sometimes, because you don't have the direction, you don't have the understanding why people get there, why this code is there, and what was the reasoning behind it. And this led me to the idea that you can actually look at code as data. So it's still code, right? But it's data, and you can extract a lot of statistics from the code base, even though usually the most simple ones work quite fine because they will show you some hotspots where you can start digging further. So code history is data, actually quite big data, quite a lot of things you can extract from like a couple of years old project. You can get a lot of things out of that. There's a lot of things happening. And there are basically 2 ways you can look at the code base. And that's what usually is happening with like static code analysis tools. You have a latest snapshot, or a snapshot from a month ago or something, and you get some statistics and metrics around that, around code structure, about the size of the code base and stuff like that. And this is okay. This is enough to look at the current point in time. But also, code, unless, of course, you put it on a shared drive, but usually you have it in version control. So you have all the history behind it, and some of the things you can actually extract from knowing the history of the code. And you may see what kind of things have been changing, what kind of things have been more active, what kind of things change together. And things like that can actually give you not only the understanding of the code as such, the current structure of the code, but actually also the behavior of the team. Because you can actually see what parts of the code have been changing, who is the biggest committer, whom you should go to talk about this component, that component, stuff like that. could be quite interesting. You can also detect things like different commit styles. For example, if some people committing have 10 commits a day, that's probably great developers. But if there's someone who's committing two times a month, something is wrong with that. Especially if the tasks that the guy's getting is something that should be committed more often. So different things, and it's always exploration. There's no predefined steps how you can extract exactly and say that this is good, this is bad. It's always exploration because all code bases are different, and it's always worth looking at different aspects of the code base, and from historical point of view and from structural point of view. So first steps that I usually do when I see a new code base. Well, do you have any ideas? What do I do?
You scan the structure of the code.
Well, kind of. I just count the lines.
It's simple.
And then the thing is that you can, of course, try to extract a lot of metrics from the code using different static analysis tools, but most of them will get you just further away, just a small step away from just counting the lines. It's a very good estimate of the code complexity, and it's a very good estimate of finding the hotspots initially. And it's actually easy to calculate, and it's kind of language agnostic, so you don't need to have special analysis tool for the language of the project. You actually can be more or less independent. And size of the code actually does matter, because that's already, if you see a code base with 2 million lines of code, there's a lot of complexity inside. You shouldn't expect it to be simple. And the thing is also that most of the code bases are kind of polyglot at the moment, so it's not that it's going to be one language. It's going to be a few languages. Java, JavaScript, Ruby, Python, whatever. Actually, in most of the big code bases, you can see all of the major ecosystems participating in that. And ratio between the languages in that code base can actually tell you something, because you can see what is the biggest skill in the company, where they're investing more, or at least in the project maybe, and you can really say something. Also, you can calculate ratio between test code, between commenting, between blank lines, and stuff like that. Of course, it's not deterministic. It doesn't, for every code base, there's no specific number that says that if it's 7% comments, then it's good. No, it's actually just an indication where you can start looking at things. And actually, regarding comments, I would say that maybe if you'd asked me 10 years ago, I would say, yeah, you should write commands. You should write as many commands as to explain everything. Now I think it's actually a bad indicator. If you have a lot of commands in business code, that means that you don't use all the facilities of the code of the programming language to express the intent of your code, and then you use commands, which probably are outdated, and it's usually a bad indication if you have a lot of commands. Unless, of course, it's a framework or some kind of library, then it's probably fine. But if it's a business code, a lot of commenting is usually a bad sign. So, this is the tool I use. It's actually written in Perl. How many of you guys have programmed in Perl? 2? Well, 3 actually, me too. And actually this is quite an old tool, but it's also still being maintained. You see, I took this screenshot a couple of months ago, and it's still active. I mean, it's still being developed. It's still a Perl script, but it's compiled into executable, so you don't need to care about installing Perl. Just get the executable, and you're done. And the thing is, it has a lot of built-in rules for calculating lines for different programming languages, and this library is pretty rich. So, and at the same time, the tool itself is very small. So this is the first step I do. I just run clock around the code base, and I get at least some understanding. So running it is very simple. Just go into the directory where the code is, and just run clock. And you can also, one thing you can use override, because new languages actually do appear, and new code bases, new tools are appearing. So you may need to modify the long file, but the default one is pretty good. The default one is pretty good, but unless you really have something very specific. This is more advanced command, but it's still doing the same thing. So it's outputting the data into CSV. It's being quiet, doesn't show the progress, and it gets the definitions, the language definition, programming language definitions from your custom file, and you're saving the CSV output to the data.csv, and you're running in the current directory. That's it. Sorry. So this will give you, actually it's quite fast. I mean, for 2 million code base, it's running maybe 20 seconds or 30 seconds. It's quite fast. If you need to define a new language, for example, at some point they didn't have a definition for Gradle, and you can add it like that. So the language file is very simple. You just specify what kind of base filtering, and because, well, Gradle is Groovy, Groovy is Java, Java is kind of C, you can use C compiler to count the lines. Because for line counting it's fine, it's totally fine. Sorry?
C is a kind of assembly.
No, well, actually no. Actually, it has a special filter for counting assembly lines. But all the C family languages, they can use C parser to actually count lines, because they use the same terms for commenting, contain the same structure, stuff like that. And you just specify the extension, and then you get the additional metric in your statistics showing you that how many Gradle files you have inside. So yeah, it is to talk about visualization. So you probably ask, where are the pictures?
What is the output from clock, so we can see what is the result of such an analysis?
I'll show you.
Okay.
Well, but I think the most important thing is not the visualization, but the most important thing actually is the data. Because if you can extract the proper data, the right data, it's no-brainer to visualize that. And I'll show you that as well. So it's probably not that hard to get that CSV file and load it into Excel. That's what I do sometimes as well, but it's boring. You know, pie charts in Excel, it's boring. It's too managerial approach. Now they have this word, infographics, that pretty much defines, well, if you search in Google for the word, you will find a lot of examples. And some of them are very artistic, some of them are really simple, but still the main, I think, difference from a chart or a plot between plot and infographics is that infographics brings some message, some idea, it focuses your attention on some certain aspect. And for that simple purpose, I actually use D3GS sometimes, not always. D3 stands for data-driven documents, and I guess you kind of know that GS is JavaScript library. So basically, it's a visualization framework that has a lot of things that it has, and a lot of libraries built on top of that allow you to do different visualizations. And if you go to their site, you will find so many different ways of doing visualizations. You'll be blown away, actually. But let me show you how you can visualize simple things. So tons of examples, tons of books. It's a very advanced library, actually. Most of the visualization things you see on the internet in HTML, most of them, if not all of them, actually based on D3 in one way or another. And this is a simple visualization that actually extracted from, based on the data extracted from Clock, injected into the HTML file with the D3.js as a core, and you get this kind of thing, which you can get it from Excel, but at least something but you can get it in D3. So I can show you. I have it here, actually. Yes. So this is this data from a small project called Redpack. So it's a Java Groovy library. And this is basically the situation that expressed from the CSV file generated from Clock. So I mean, it's maybe 1 minute, and you get a nice visualization of that. The thing is that, of course, you have to generate this HTML file. It's probably not the easiest thing, but there are many templates, many examples on the internet, so you can. So that's why I'm saying it's more important to get the data, and you will actually find the template that you want. And I can show you how it looks. And well, I have it here. So basically, yeah, this is the HTML. It has a lot of JavaScript inside, but I'm not focusing on that because I actually got this template for someone on the internet. And what's important is this JSON file, which I just took the CSV file, transformed it to JSON, which is a simple script again, and I get it into HTML. And as you guess, we can visualize this in this way, many different things. And the more you play with that, the more templates you will come up with, and the more things you will be able to visualize based on different data. So I'm saying data is more important the template. Okay, let's go further. And as I mentioned, there are many alternatives and many libraries available on D3.js. So it's like Viz.js, Raphael.js, Sigma.js, a lot of things. And just search for that and you'll be blown away. So it's so many things. I think that's the best thing of JavaScript for me. Not the other parts, but the visualization parts in JavaScript are great. Another thing I use quite often is called, I think it's pronounced Tableau. Maybe not, I don't know. Tableau Public. It's a commercial product and it costs quite a lot. But the public version is free. The only problem, you can't really save your visualizations. But still, it's a good tool for trying out different types of visualizations because it actually has a lot of different things. And you can load your data inside, play with visualizations. And if you need this visualization only like to prove something or to show your manager that how bad is this code or how good is this code, you make a screenshot and send it, and then you forget about it. But you still have the data. You still have an ability to make a D3 template after that, and maybe make some automatic process out of that, and do some visualization. Some things. I have Tableau Public running here. So, for example, here I took clock data again from Kotlin. Do you know Kotlin? Who knows Kotlin? That's a language for JVM. And basically that's one IntelliJ idea is using internally to build their IDEs. So I took that codebase and I split the codebase into test code and non-test code. And surprising thing is that, so I can actually show it here. You can actually see that the amount of Kotlin code is, of course, Kotlin is written in Kotlin himself. There's a lot of Java code as well, but Java code has more test code. This is the black line determines the amount of test code, and the blue bar is the just code without tests. And you can see that amount of test code in Java is bigger than the amount of test code in Kotlin, and that's at the same time the Kotlin code base is bigger for the Kotlin itself. So it's kind of interesting observation you can get, and of course you can start digging further and get clock information from like subdirectories, subcomponents, and then go further and further, and probably you'll find something more interesting. So, but to get a implicit understanding, you can actually just use the simple visualizations. And as you see, there's some weird stuff like IDL. It's not, well, it's probably something that should not be there, but it's there. So it's again something interesting to see why Kotlin has IDL files. If you don't know what is IDL, it's like kind of Corba-based thing that was that long ago. So it's kind of surprising to see it here. Maybe it's a fault of clock, maybe it's a fault of Kotlin, I don't know. But it's really an indication that I can look inside. Also something like Maven and Groovy. That's weird. Why don't they use Gradle? That's another story. That's kind of interesting to see. Also, you can use this like different tree map diagrams here, and you can play with data very easily. And you can place, for example, this is the number of files in each language, and this is the number of code lines in each language. So even though the amount of Kotlin files is kind of bigger, but the amount of code lines in Java is kind of almost the same as in Kotlin. So that's probably because the Kotlin is less verbose than Java, so we can see that on this chart as well. It's kind of interesting as well. And as you see, because we just loaded the CSV file into this tool, we can just take any metric and put it into, let's say, command lines here, and we get command lines instead. So the coloring now is based on the command lines. But we can also see how commanded the code is. So again, Kotlin is most commanded, obviously, but just because it's the biggest part. But you will also see that all the things like Maven IDL suddenly disappeared because they just don't have commands. So it's really good for exploration, and when you have something that you like, you can actually start finding a similar template in D3 and visualizing some same thing. It's not trivial, but it's still easier to play with the data in a tool that allows to do it quickly. And then when you're happy with your visualization, you can go and automate that and have a template that is reproducible and free. Okay. Another thing you can do actually, and that's what I do a couple of times, is you can actually design your own infographics. And again, you don't need to be a graphical designer here. You just can use simple tools like SVG. And the tool I usually use is called Inkscape. It's a free open source SVG editor. And as you see, the graphic that I created actually is also for Rackpack. And well, I mean, it took me maybe 30 minutes to create it. I hope it's nice. At the same time, it's just telling some information to the reader. Plus, we can actually, because it's SVG, it's basically XML, we can use it as a template and insert the numbers with simple replacement and generate the image and insert it into HTML and get nice visualizations, send it to the team. So it's not that hard. This is a visualization. I can actually show you that it's not a fake. It's true. I can move things here. And I think the main goal for this kind of infographics or visualizing important information, the coloring is kind of bad because if you see it here, it's a bit different color.
Okay.
But anyway, I think the most important thing is that we have to highlight the numbers and make them big, but at the same time, try to extract the important things that may be interesting to the team members to see every month or so. Okay, let's go next. So another thing we can do with the code, not only is analyzing its structure and digging into the structure, we can also do temporal analysis of the code history. And well, GitHub has some charts. Also a tool called Fisheye that does that. But the tool that I like a lot is called Gores. How many of you guys have seen Gores visualizations? James has another one. So yes, Gores is basically it's video maker it makes a video from your Git history. So it's very nice. And the only thing you have to have is the git log of your history, and it will show you a number. So this is how the log format looks. So it's not really visual at this point, but let me show you what could be done here. So, Gores. I run this long command. So basically, this is the history of the Kotlin project starting from 2010. And you see that the small persons are actually the committers, and each dot is a file, each root is a directory, and you can see the data on top. And I think now they should start happening like active phase of the project, because there you will see a lot of things being added and then deleted. And you can see the names. So and you can also see the number of files growing. So it's kind of started. The Kotlin project started as more as a Java project, and now,
Wow. That was a big refactoring there.
So actually, on YouTube you can find a lot of Gores videos, and one of the, to me at least, the most interesting one is the history of Linux kernel, where they actually have history since 1991. And you can see, like, the first guy obviously was Linus Torvalds running around, but then in the end it was a very huge kernel, and a lot of things were being refactored, and that's kind of fun to watch. And you see at this point we already have Kotlin dominating the code base, which means that Kotlin, well, now Java again wins. That's kind of interesting, right? Class files, what's that? And the thing is, you see, something has been deleted now. Now, you probably edit again.
So you delete the entire branch.
It's a single branch. It's master branch.
No, I meant as branches. You delete a big part of the code.
So when I show these visualizations to managers, to developers, they say, "Wow, cool! That's a cool thing. Well, that's me running there. Oh, nice." But then after that, they say, "But well, it's fun. But how do we use it?" And well, I would say, well, you can't really use it. Just it's only for communication, for fun, and because like human beings, they're not really good at consuming multi-dimensional video messages. It's probably not worth using it for finding kind of statistics, but it's still quite kind of interesting to see the main events in the history of the project, to see where the big refactorings were, who are the main guys running around some components, and you can always limit that video to a certain period of time, to a certain directory. You can actually filter some of the files, so you can actually, when you start digging, you can get some useful things. And what I actually did a couple of times is that we generated this video for sprints. So for each sprint, we had a video of what things have been changing, and we have been comparing what kind of activity, how active this sprint was comparing to the previous sprint. That was that started some discussions. That was kind of interesting. So I think these videos, they mostly are for starting discussions and for exploring, but not really for driving some decisions in the beginning. And we can kind of move the timeline further. So because it's only based on the Git log, it's showing only the files that were changed recently, and if files were not changed for a while, then they actually disappear from this picture. So you can show, this is actually only the active tree, the files that were changed for the last 5 days since the moving target. So yeah, it's fun. Okay. I don't have much time left actually, but we have time to finish. Another good tool that I kind of learned about not so long ago, it's called CodeMat. It's from Adam Thornhill, who actually wrote a book about not about the tool, but he's using the tool in that book a lot. And it's also a kind of data extraction tool from Git log. So you can fit it a Git log and you will get some useful statistics. And the way you run it, you can just mat Git log this type Git. You can also fit some version there, and then you also get the number of the amount of the report that you want to get is summary, and it actually supports many other different analysis types. So I think it's growing now. So it should be even more now. I'll show you a small demo that again is generated from output of CodeMat and combined with the D3 template. This gives you this one. So this is the picture of Hibernate codebase. How many of you guys know Hibernate? Oh, unfortunately. So yeah, I know Hibernate as well, yes. So this is actually a combined picture, so it shows the structure of the modules inside Hibernate. Plus, the coloring is not that good because here I see it much better. But the size of the block is basically the size of each bubble is basically the size of the code inside that block, inside that module, and the color of the block is how often it was changed. So, and we can actually zoom in. So, actually here we have something like hotspot. So, relatively big module size compared to its neighbors, and it's also red because it was changed a lot. So, we can actually see. Come on, zoom in. So we can see that this package entity, well, obviously it's ORM, it's changing a lot. So we can see that, using this kind of utility, we can identify what are the most changed components and the biggest components in the codebase, and start analyzing from there. So it's a good way to find hotspots, and to find hotspots not only based on size but also on changeability of those components. That's very helpful. I hope you like it. Okay, I have a few minutes, but let me finish it. Let's try to think about it as code history more like big data, and let's use some of the big data or NoSQL products to actually index the data. So I use Elasticsearch for that. Well, I guess most of you guys know Elasticsearch, right? Yeah, okay. Well, it's a NoSQL full index database. So the way you can put data into Elasticsearch is simple HTTP request. So you can just index for example, you can take your git commit information and using curl or any other HTTP client, put the data into Elasticsearch. So just say this is the index name, this is the document type commit, and this is the ID of that commit. And of course, you can put a lot of other information here. And I wrote a simple script that just puts that all into Elasticsearch. And the thing is that Elasticsearch is not only good for search, but it has very nice visualization interface on top of that called Kibana, which allows to visualize things very nicely. So it's flexible. Yeah, Kibana is a visualization platform. Again, internally, actually, Kibana uses D3 a lot. They also use their own libraries, but D3 is also one of the backbones of Kibana. So yes, I will show you soon. So this is the dashboard actually I created from GitLog. I will show you how it works. Okay, let me show you. So this is Kibana interface, and I loaded the Ratpack library GitLog into Kibana. And the thing is that you can actually search for make pretty much free text search over anything, over file names, over commit messages, over authors, and all that information is inside Elasticsearch, and it's quite fast. So now I kind of have the filter of last 90 days, but I can actually put it to any period, like last 30 days, for example, and I can see the activity of the project for this last 30 days, and I see that there's not, well, there's some big activity, some things that will kind of not doing anything. And also there's a visualize bar where you can actually get that data and put it in a different form, in a pie chart, in a vertical bar, in whatever you want. And for example, I can take, let's say, files, and I want to actually plot what are the most kind of changed files within the last 30 days. So I can take the file name, and I can plot it on like this. And as you see, it's the top 5 files, but I can say like top 15 files. And I can see that mostly, for some reason, they like changing Gradle files. So that's kind of weird, for a project that is actually not well. The project is actually already 6 years old. So for 6 years old project, changing build files that often doesn't sound very well. It sounds strange. But the thing is actually the Gradle files, I think they contain some release information. That's why actually they change automatically from time to time. So we can actually remove that from the search, and we will see some different picture. The thing is with these visualizations, you can save them. You can save them together with the queries. You can save them together with all the filters, and you can also build dashboards out of them. And that's what I did. I built a dashboard with information from the following. So yeah, maybe this one is better. It's full screen. So and the thing is, this is the tag cloud of commit messages. So I can see that during the last 30 days we have a lot of fixes, and also, well, this is logical because it's the latest version of Ratpack that was released just there, as you can see. And there's a next version, 1.3.3. A lot of merges coming in, versioning and stuff like that, request. And you can see that there's one dominator. There's one guy who's actually doing most of the commits. And we can also see what are the most changed files in that period. And we see the commit count, and we can see how many lines of code have been deleted, have been added. And the thing is that it's not only like a static picture. You can actually go inside here and write some queries. So for example, if I don't want to see this Luke Daly, who is obviously dominating a lot, I want to see the other guys to know what are they doing. I can actually do author. I think it's not, because every field that in this, the whole Git commit is indexed as a document with many fields in Elasticsearch, and you can filter on any field. So I can You do like this. Didn't really work. Well, it was tough.
Is it the author field or is it committer?
Sorry?
Is it author really?
Maybe not.
Committer.
Let me check.
But you can just say not Lucas.
Yeah, that's also possible actually. You can say not. Yeah. So we can see that when Luke is not there, the picture is a bit different. And well,
Less fixes without Luke.
yeah, no fixes. Well, less, fewer fixes without Luke. So Luke is kind of the main fixer in the project.
More point than merging.
And I mean, of course, it's at this point it doesn't make a lot of sense. But if you start digging into the data and you start exploring your data about your code, you can actually extract quite interesting things like what are the files are changing together, what are the who is the biggest committer today, yesterday, and for the whole month, and why he did it, what are the files he's mostly specializing in, and there's a lot of markdown files change. So obviously, probably Luke is committing a lot of code, but the other guy is kind of committing to the documentation, which is also good. Okay, I hope you liked it. Well, kind of running out of time, right?
The last one.
So there's another tool I wanted to show, but not much time left. So there's a tool called T.A.K.E Assistant. It's mostly Java for Java code bases, but it also can be extended to other code bases if you write a plugin for that, of course. It's just another NoSQL database behind the scenes called Neo4j, which is a graph database, and you can index your structures of your project into this tool, and you can using T.A.K.E Assistant you can start a local Neo4j server and have an ability to query data about your project. So, for example, I loaded 2 Hibernate versions into the database, and I can actually use the graph query to verify what are the classes that have been deprecated in those versions, and I can get again some input from my visualizations. Also, you can actually verify what are the classes that are present in version 4 of Hibernate and not present in version 5 of Hibernate. And you can get some useful information out of that. So I'm still quite new to that, but I see the quite big potential of having an ability to run queries against the structure of your code, and there are tooling for that. So, and that's again, it's all free. It's not you don't need to buy any super big licenses. You just index the data and make queries. So that's what I find the most intriguing part of visualizations. Yeah, this is the Neo4j query language called Cypher. So you can see it here. We're trying to find classes with which have methods, and we just count the number of methods per class. So we can actually find the classes with a bigger number of methods. And because it's just a query, we can execute it anytime. And we can actually have some alerts or some special rules on top of that, and also visualize that in one way or another. I hope you see the potential. That's pretty much it. So the conclusion is that, try to extract data from your code, try to visualize it using simple tools, databases, NoSQL databases, search for facts and knowledge, because it's really an exploration, and each code base is different, and each team is different, and become data scientists this way, or I would actually call it data journalist, but anything you prefer. Some reading material. The guy who wrote the code mat tool, Adam Turnhill, there's a book he wrote, Your Code is a Crime Scheme. Very interesting one. There's a lot of books on software metrics. Well, maybe not a lot, but some of them are there. So, software metrics metrology. Also, actually, if you just go to Amazon or any other book site, you will find tremendous amount of these 3 books. D3 cookbook, D3 tips and tricks, and there are many of them. I will share the slides, so the links are shared on the slides. I will just share it a few minutes after the presentation on Twitter. And I think, that's it. Thank you, guys.